Hi, welcome back. As I promised, I want to do the second part of 5.1. Now, the reason I broke this out is because it can get a little tricky, and I wanted to be sure we had time without getting too long on our videos. So, in the last video, I told you that quadratic functions have a generic form of y equals ax squared plus bx plus c. I also told you that you could find the vertex by finding the x half from negative b over 2a, and then plugging that back in to get y. There is another form for the equation of a parabola, or for a quadratic formula. I call it the vertex form. If you ever take a analytical geometry class or calculus class, you will sometimes see this called the standard form. What it looks like is this. It says y equals a times x minus h squared plus k. This is another form of the equation of a parabola, and we can go back and forth between the two forms. If we go from here to the expanded form, we just expand everything out. If we're going from the generic form, what I call the standard form, to the vertex form, we're going to use a tool called completing the square, which you hopefully remember from Math 95, but I will show you. The reason why this is valuable is because if we do this, we can read the vertex directly from the equation. Let me give you an example. If I have the quadratic equation y equals just a minute, let me find one. Negative x minus 3 squared plus 1. We already know quite a few things about this. We know, and the A is still what tells us which direction it opens. So what we know here is we know that A is negative 1. So that means that since that is less than 0, we've got a parabola that opens downward. If we compare this to my vertex form, we can see that h is 3 and k is 1. So the vertex is at 3, 1. Okay, we find the x and y coordinates just as usual by plugging in 0 for x to find, or sorry, x and y intercepts as usual by plugging in 0 for x. So let's find the x-intercepts by plugging in 0 for y. X-intercept means y equals 0. So that means we're going to solve the equation 0 equals negative x minus 3 squared plus 1. Now you may be thinking to yourself, oh, now I have to FOIL that out and distribute that negative sign. Let me show you an easier way. We only have x's in one spot. The only x, whoops, sorry, I added a negative sign. The only x that I have is right there inside that set of parentheses. So I'm going to start by just subtracting 1 from both sides. And I end up with negative 1 equals negative x minus 3 squared. So I'm going to get rid of that negative sign by dividing both sides by negative 1 or multiplying both sides by negative 1. Turns out to be the same thing. I end up 1 equals x minus 3 squared. Now comes the magic. If I've got anything squared equals a number, so what I have here, besides crooked pages, is 1 equals something squared. It doesn't matter what's inside those parentheses. I can take the square root of both sides. I just have to remember to take the positive and negative square root, because there are two numbers that I can square to get 1. What that means then is I end up with positive or negative 1 equals x minus 3. Now I want you to be a little careful here, because what this means is that x minus 3 equals 1, or x minus 3 equals negative 1. So we're going to get two x-intercepts. We're going to get x equals 4, or x equals 2. And my x-intercepts are at the point 4, 0, and 2, 0. We find the y-intercepts by setting x equal to 0. So remember that our equation, our function is y equals negative x minus 3 squared plus 1. Plug in x equals 0. Negative 0 minus 3 is negative 3. Squared is 9. Negative 9 plus 1, negative 8. My y-intercept is at the point 0, negative 8. Okay, now what I want you to remember is that all of this started with this weird looking form for the equation of a parabola. But you'll notice I didn't have to factor a thing. I didn't have to pull out the quadratic formula. And I just read my vertex right off of my equation. So let me show you how we get there. It's handy. Okay. We worked with completing the square. When we were deriving the quadratic formula back in Math 95, when we first learned how to solve quadratic equations. But most of you probably don't remember how to do it, or what it means or what it does for you, so I'm going to show you how to do this. So we're going to start with the simplest case, which is y equals x squared plus 2x minus 3. And it is the simplest case because I have a 1 right there. So here's what we're going to do. We're going to complete the square. Now, what that means is the first thing we're going to do is we're going to rewrite our equation. And we're going to put the first two terms, whoops, sorry, that's a 2, inside a set of parentheses. And I'm going to add something. I'm going to put down the minus 3. And because I added something, I now have to subtract something. And actually, we're going to come back to this one because I'm going to start with the more complicated piece first. That will be less confusing. So let's start with the hard one. Let's start with something that looks like y equals 2x squared plus 4x minus 6. Okay, we're going to put this into y equals a times x minus h squared plus k form. We're going to follow these steps. If you follow these steps, it works every time. Step number 1, put the first two terms inside a set of parentheses, and then write down the last constant term. What we need to do now is factor a, whatever a is, out of the first two terms. In this case, I have a 2. So I'm going to pull that 2 out. And this time when I write my parentheses, I'm going to leave a spot to add something. And I'm going to leave a spot to subtract something. And now what I'm going to do is I'm going to add something inside those parentheses. And what I'm going to add is 1/2 of b squared. So I'm going to take this number, whatever it is, divide it in 2 and square it. So 2 divided by 2 squared is 1. Okay, now I just added something to my equation. Remember, good algebra says I can't do that unless I undo it. Now, in earlier courses, we said that if we added something to one side, we had to add that same thing to the other side. We can also, if we add something, we can subtract that same thing. So we end up adding 0. My math teacher used to call it dirty trick 997. Okay, but what did I actually add? Think about undoing this operation. If I undo this, I'm going to have to distribute this 2 all the way through. So what I actually added was not 1. I actually added whatever a is, in this case 2, times the number I wrote down inside those parentheses. Sit with that for a minute and think about it and let it make some sense. Okay. So now what I have is y equals 2 times x squared plus 2x plus 1 minus, combine our like terms back here, 8. Okay, here's the magic, and this is why it's called completing the square. Whenever we do this, we will always end up with a perfect square trinomial, which means it always factors the same way. It will always factor as x squared plus the square root of whatever I added. In this case, I added 1. So that guy always factors as 2, in this case, times x plus 1 squared minus 8. Okay, we're almost there. Look at our standard form. It should be y equals a times x minus a number squared plus another number. I've got plus 1. Plus 1 is the same thing as minus a negative 1. So let's just rewrite this as x minus a negative 1 squared. And now I've got plus 8, which is plus a negative 8. Now, if I compare that to my standard form, I can see that h equals negative 1, k equals negative 8. This is the vertex form. In order to read it, it might be easier to write it this way. But either way, your vertex is at the point negative 1, negative 8. Okay, I hope that made sense. You may need to review completing the square if you're struggling with this. I do want you to be able to at least read the vertex form. I'm not so picky about you being able to go back and forth between them so long as you can graph a parabolic equation one way or another. I'm not going to give you a quiz on this one, and I will see you again soon.